Welcome, class. In this video, we will go over lesson 1-6 in our textbook. In this lesson, we'll be solving for variables. Now, you may ask, why do we even need to solve for a variable? Why don't we just evaluate it with the known values? For example, if I said area is equal to base times height, and if I tell you the base and I tell you the area, we know we could just solve for the height. But sometimes when we have a more complicated equation, a longer equation, it may actually make it less difficult if we go ahead and solve for the variable individually. Like I'll give you a gravity equation here. Mass 1, mass 2 over the radius squared. This is the actual equation to calculate this force of gravity. There's a universal G, a mass of the individual, the mass of the planet, and the distance between the individual and the center of the planet. If we were to solve for any one of these variables, it may be easier to actually isolate it first before we plug in the values. Now, in our assignment, there's a good example at the very top of these pages. This is why I like to use these mastery worksheets. It has a little bit of explanation of solving for variables. And this is something I would like you to do on your own. Okay. We just go straight to the homework here so we can look at each problem. Number 1. P equals 4 times S. Now, this is the equation to find the perimeter of a square. The perimeter of a square. We took all 4 sides. We could figure out the perimeter by just doing 4 times S. In this problem, it's asking us to solve for the variable S. We always use the inverse operation when solving for a variable. Right now, it's 4 times S. The inverse operation of multiplication is division. So we will divide both sides by 4. The 4's, of course, cancel on the right, and we now have S equal to P divided by 4. And as always, we will always box our answers. For number 2, A plus B plus C equals 180. This sounds like we're trying to find the angles within a triangle. This is going to be A, we'll call this B and the C, because we know the sum of the angles is 180. So this is probably for a triangle problem. It says here, solve for B. Right now, the other variables on the same side as the variable, the other variables, are adding. So we're going to do the inverse operation, which is, of course, subtraction. We can subtract C from both sides. So right now I have A plus B is equal to 180 minus C. Now, how do we get rid of the A? We get rid of the A by subtracting A from both sides. We cannot combine different variables. We can only combine like terms. So for this problem, they're all different terms. We have 180, which is a constant, and we have a variable A, and we have a variable C. So we'll leave the answer just like this. B equals 180 minus A minus C. Next problem, we're solving for the variable K. P equals K times T over V. Now, right now, K is being divided by V, and it's also being multiplied by T. We could get rid of the variable in a step here. We can just multiply both sides by V, and that would get rid of the V's on both sides. So we'll have P times V is equal to K times T. We're still solving for K. Right now it's K times T. So the inverse will be division. So we'll divide both sides by T. So we get K equals PV over T. For the next two problems, numbers 4 and 5, on our mastery worksheet. They give us the equation to find the volume of a square pyramid. A square pyramid, which would look something like this. It's supposed to be a square. The volume of a square pyramid is the volume of the object times 1/3. You'll see this 1/3 a lot in all your other problems here. We'll see this 1/3 a lot in a lot of volume problems. Whenever you find the volume of an object and it ends in a point, it's going to have 1/3 in front. This 1/3 was actually discovered through calculus. So we didn't actually know the 1/3 was correct until around the 1600s. I believe the ancient Greeks figured it out first, but they figured it out through experimentation. Now in number 4, it says to solve for the variable w, the width. So we need to get rid of the 3 in the denominator first. So we'll multiply both sides by 3. So we'll get 3v is equal to L times W times H. Now we need to divide by, because we're solving for the variable, we need to divide by L and H. And we can divide by more than one variable at a time because it's all multiplied together. It's like one part. So the final answer would be W equal to 3 times V divided by H. Divided by L times H. And for number 5, we're asked now to go ahead and plug in these numbers and solve for the width. We know that the volume is going to be 560, so the width is equal to 3 times 560 divided by the length times the height, which is 10 times 14. I don't know if we can reduce this a little bit. Let's see. The 10 cancels with the 0. 14 goes into 56. How many times? I believe it goes in 4 times. And then 3 times 4 is 12. So the width comes out to 12. And the units are inches. Because the volume is inches cubed, the length, the width, and the height must all be measured in inches. Let's go to the second page. Again, we have another example here where in this case they're solving for y, and they first got rid of the 10 on the bottom here by multiplying both sides by 10. So the 10s would cancel. And then we have y minus z, and we're still solving for y, and they just added z to get to the final answer. So you can feel free to look at these examples later in your worksheets. Let's go ahead and solve the homework problems. It says here, state the inverse operation to perform when solving for the indicated variable. Well, to solve for z, right now it's x plus z. It's x, we're adding x to z. So we need to subtract x to z. So the inverse operation will be subtraction. We're using what's called the subtraction property. And I'm sorry, all we have to do is actually state the property. And the proper term for this would be the subtraction property of equality. But for now, we'll just call it the subtraction. That's the proper term would be subtraction property of equality, SPOE. For number 7, we're solving for the variable g. Well, in order to do this, we have to first multiply both sides by the number 2, because we need to get rid of the 2 in the denominator. So it's going to be multiplication property of equality first. We'll just call it multiplication. Once we do multiplication, if we multiply both sides by 2, we will get f plus g is equal to 2 times h. And we're solving for g. So the question is, how do we get rid of the f? How do we move the f to the other side? Right now it's a positive f, so we will subtract f. So the next inverse operation will be subtraction. Number 8, we're solving for the variable s. In this case, we could multiply everything by 5, or we could add 3r to both sides. I think it's better to add 3r to both sides. Because if we multiply each term by 5, we also have to multiply the negative 3r by 5. It just makes the numbers bigger. So let's go ahead and add the 3r to both sides. We'll call this addition first. Once we do addition, we're going to get t is equal to, t plus 3r. So we added 3r to both sides. T plus 3r is equal to s over 5. And then to get rid of the 5, we're going to have to multiply both sides by 5. So the final property would be multiplication. Number 9, solve for the variable a. Right now it's 3 times a times b. So both 3 and b are multiplied to a. To get a by itself, we will use the inverse operation, which is division. So we will divide both sides by 3 and b. So a equals c over 3b. Number 10, solve for the variable z. Again, we have to decide, should we multiply both sides by 3 first? Or should we subtract both sides by x first? I would prefer subtracting by x first. So we have y minus x equals z over 3. Now we have to get rid of the 3 in the denominator, so we'll multiply both sides by 3. And we get 3 times y minus, don't forget to distribute the 3 to both terms, 3 times x equal to z. Now for the final problem, we're solving for the variable m. We can't subtract the 3 from both sides because the whole quantity, or excuse me, the whole expression is being divided by n. So we need to get rid of the n first. Now to get rid of the n, we will multiply both sides by n. So the n's would cancel. And we will get m plus 3 is equal to p times n. Now in math, we typically write in alphabetical order. So I'm going to write the n first before the p. But p times n and n times p would be the same thing. But we like to go in alphabetical order. Now for the final step, we just need to subtract 3 from both sides. So we get m equals np minus 3. Okay, well this concludes the lesson over 1-6 mastery.